Humans were controlling fire 790,000 years ago. Not 10,000, not 50,000, 790,000. And here's the problem. There were no matches, no lighters, no gas, no electricity. If that fire went out, what happened next? Because finding fire isn't the same as controlling it. Lightning can make fire, wildfires can make fire, nature can do it for you. But keeping a flame alive, choosing the fuel, protecting it, using it again, that is technology. And buried beside an ancient lake in Israel is evidence that someone was already doing exactly that nearly 800,000 years ago. But the strangest part isn't the fire. It's how archaeologists know the fire was human. Picture the environment. The sun is gone. The temperature drops. Wind moves across the lake. Your body is losing heat, and you are not wearing modern insulation. You don't have a synthetic sleeping bag. You don't have a heated shelter. You have skin, muscle, a stone tool, and darkness. Now add another problem. You can't see. The forest doesn't become less dangerous at night. It becomes harder for you to see the danger. A predator doesn't need to become stronger. It only needs to become harder to detect. This is why fire matters, not because it is beautiful, because it changes the rules. A small flame creates warmth. It creates light. It creates a visible boundary. And potentially it gives you access to food that is harder to use raw. But there's a catch. None of those benefits matter if you can't control the flame. So here's our first question. Did early humans simply find natural fires and keep them alive? Or had they already learned something much more difficult? Fire is one of archaeology's worst pieces of evidence. Think about what happens when a camp disappears. Wood burns, ash scatters, rain moves sediment, wind carries charcoal away, the shelter collapses. After a few centuries, almost everything can vanish. After hundreds of thousands of years, the problem becomes extreme. So archaeologists face a strange problem. They're looking for something that destroys its own evidence. And that means a burned stone isn't enough. A stone can burn because a wildfire passed over it. Lightning can start that wildfire. A natural fire can leave thousands of heated fragments behind. So how do you prove that a fire belonged to humans? You don't look for one smoking gun. You look for a pattern. And that's where Gesher Benot Ya'aqov becomes so interesting. Around 790,000 years ago, the area around Gesher Benot Ya'aqov in what is now northern Israel was a lakeshore environment. Hominins repeatedly occupied this landscape. They left stone tools, animal remains, wood, plants, and something else, burned flint. At first glance, burned flint sounds unimpressive, but archaeologists noticed something strange. The burned pieces weren't simply scattered everywhere. They were concentrated in particular locations. One cluster contained a very high proportion of the burned micro-artifacts recovered from the excavated area. Researchers interpreted these spatial concentrations as evidence for what they called latent or phantom hearths, whose original organic structure had vanished, leaving behind the spatial fingerprint of the fire. And now, the mystery gets stronger. If the burning happened randomly, you'd expect random distribution. But here, the heat damage was concentrated. Then scientists asked another question. Was the center actually hotter than the edges? Scientists used thermoluminescence analysis on tiny flint artifacts. In simple terms, the material retains information about heating in ways that can be measured. And the result was revealing. The flints closest to the reconstructed hearth center showed the strongest heating signatures. As researchers moved outward, the heating generally became weaker. That's exactly the kind of spatial pattern you'd expect from a concentrated heat source. Hot center, cooler edge, scattered material beyond. The archaeological layer was beginning to look less like a landscape where fire happened and more like a place where someone managed a fire. But even now, we still have a problem. A hearth proves fire. A hearth does not automatically tell us who lit it. So what else was happening around that fire? The ancient lakeshore was full of resources: fish, plants, seeds, nuts, wood, large animals. And the archaeological record shows people exploiting many of them. At Gesher Benot Ya'aqov, researchers recovered a remarkably diverse plant assemblage, including edible fruits, seeds, nuts, and underground storage organs from deposits around 780,000 years ago. Now here's the interesting question. Why collect all these different foods if you can only use the easiest ones? Because fire can expand the menu. It can transform texture. It can make some foods easier to process. And in 2022, researchers reported an even more extraordinary result from Gesher Benot Ya'aqov. They found evidence consistent with cooking fish around 780,000 years ago. The key clues came from fish teeth associated spatially with the site's burned flint concentrations. X-ray diffraction analysis suggested the fish had experienced relatively low temperature heating, consistent with cooking rather than intense burning. The study described this as the earliest evidence then reported for cooking by hominins. Now the story changes. Fire wasn't merely keeping someone warm. It may have been changing what humans could eat, but that creates another question. question. If the fire was useful enough to cook food, how did they keep it going? Imagine waking up before sunrise. The fire is almost gone. There are only red coals. The wind is cold. You have two choices. Let it die and start again somehow, or protect those embers. Feed them, move them, carry them. This is the difference between using fire and depending on fire. Once a group relies on it, maintaining it becomes a responsibility. Someone has to gather fuel. Someone has to protect it. Someone has to know which wood works. That means fire creates a strange new survival task. You have to take care of the thing taking care of you. And that could explain something important about human evolution. A technology doesn't have to be complicated to become powerful. It only needs to create a dependency that rewards knowledge. Now we reach the question that sounds obvious. Did these humans know how to make fire? And here, we need to be careful. The evidence from Gesher Benot Ya'aqov strongly supports the use and control of fire. But controlling fire is not the same thing as independently producing fire on demand. That distinction matters because the archaeological record for early fire is complicated. Some sites have older traces of burning, but researchers must separate deliberate human activity from natural burning. One particularly important example comes from Wonderwork Cave in South Africa. Researchers reported microscopic evidence of burned bone and plant ash from deposits approximately 1 million years old, deep inside the cave. They argued that the burned material was preserved where it accumulated rather than simply being transported there by an outside wildfire. So now we have something even more interesting. Possible fire use reaches back roughly 1 million years. But the story is not that someone invented fire on one particular Tuesday. Fire use appears to have emerged through a long, messy process, encountering natural fire, keeping embers, maintaining flames, using fire repeatedly, learning what it can do, and eventually, perhaps, learning how to create it. That uncertainty actually makes the story more fascinating, because there wasn't necessarily one invention. There may have been a chain of discoveries. Now ask yourself, what happens when an animal gets several extra hours every day? The obvious answer is that it can do more. Before controlled light, darkness creates a natural boundary. But fire pushes that boundary backward, a little, then a little more. Now someone can repair a tool, process food, watch for danger, care for another person, or simply remain awake. Researchers have suggested that ancient hearths could have created activity zones around which different tasks were organized. At Gesher Benot Ya'aqov, spatial studies identify activity areas associated with hearths and nearby processing behaviors. And this gives us another reversal. Maybe the biggest advantage of fire wasn't simply heat. Maybe it was coordination, a central place where people gathered, where knowledge could be demonstrated, where techniques could be copied, where young members could watch older members work. Imagine how much knowledge is hidden inside something as simple as feeding a flame. Use dry wood, not wet wood. Shield it from wind. Don't smother the coals. Don't place fuel too quickly. Learn the difference between smoke and heat. Learn how long embers survive. None of that has to be written down. It can be shown and copied and remembered. That means fire may have amplified something humans were already unusually good at: social learning. Here's the surprising part. A fire doesn't just preserve heat. It can preserve behavior. An older person demonstrates something. A younger person watches. The younger person repeats it. The group remembers what worked. Generations later, the behavior survives even though the original inventor is long gone. That is what makes technology different from instinct. A wolf doesn't need a teacher to know how to be a wolf, but a human doesn't automatically know how to construct every useful tool. Someone has to learn it. Fire therefore creates a strange feedback loop. Fire rewards knowledge. Knowledge improves fire use. Better fire use improves survival, and survival preserves the knowledge. That may be one reason fire becomes increasingly important across later archaeological sequences. At several later Eurasian sites, evidence for habitual fire use becomes much more common than in the deepest early record. Reviews of the archaeological evidence show a broader intensification of fire use after roughly 450 to 350,000 years ago. Even though earlier examples remain important, fire didn't suddenly appear everywhere. Its role appears to have expanded. And now return to the original question. Why did controlling fire matter so much? Was it warmth? Yes. Was it light? Yes. Was it food? Increasingly, yes. Was it protection? Possibly. But none of those explanations is complete, because fire's greatest power may have been what happened between those benefits. It connected them. A tool gives you one ability. Fire creates an entire system of abilities. It changes food. It changes time. It changes space. It changes behavior. It changes social interaction. And eventually, it changes the relationship between humans and the environment. That is why a 790,000-year-old fire site is so much more than an old campfire. It is a snapshot of an animal beginning to escape the limits of its own body. Humans could not grow thick fur overnight, so we made warmth. We could not see in darkness, so we made light. We could not digest every resource, so we altered food. We could not physically dominate every environment, so we altered the environment around ourselves, and that's the real evolutionary story. Not that humans became the strongest animals. We didn't. Not that we suddenly became smarter than everything else. Evolution does not provide neat moments like that. Instead, humans accumulated small advantages: a better tool, a safer camp, a new food, a better technique, a shared memory, a controlled flame, and then another generation inherited all of it. So imagine that lake again. 790,000 years ago, the sun has disappeared, the wind is cold, the animals are somewhere beyond the darkness. A small human group sits beside a controlled flame. There is nothing modern about it. No city, no electricity, no steel, no written language. And yet, someone understands the fire. Someone knows how to keep it alive. Someone knows what to feed it. Someone knows what it can do. Someone probably learned that knowledge from someone else. That is the part we can almost miss when we stare at a number like 790,000. The number sounds impossibly distant, but the problem those people faced was not distant at all. They were cold, they were hungry, they were vulnerable, and they found a way to make something outside their bodies work for them. We often think human evolution was about becoming physically better adapted to the world, but fire suggests another possibility. Maybe our greatest adaptation was learning that we didn't always have to adapt our bodies to the world. We could adapt the world around us. And it all began with something almost absurdly small: a flame, not civilization, not technology as we understand it, just a controlled patch of light in a world that was otherwise dark. One flame, one night, one group of humans refusing to let it die. And somehow, 790,000 years later, we're still sitting beside it.